I want to talk about rational functions. The rational functions is given by, we call the given name, which is the Rx or f(f), doesn't matter. Okay, so here I use Rx, which is equal to P of x over Q over x. So where P of x is a polynomial, P of x and Q of x are polynomials. So in other words, the general form for Rx can be written as a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus and so on, plus a1x plus a0, right? Over q is also a polynomial. We should not use the same n. We use another letter m. So b sub m times x to the m plus b sub m minus 1 times x to the m minus 1 plus and so on, plus b1x plus b sub 0. So this is the rational function, the typical form of a rational function, right? So the rational function has a very special things, which is called asymptotes. Asymptotes. So the asymptotes have the first one, which is called the vertical asymptote. What does this mean? So the vertical asymptote means when the x is very close, so this is the vertical dashed line, right? Then the curve will be very close to this dashed line when x is very close to a number. If this is the vertical asymptote, this is x equals h. So if x is very close to h, then the curve will be very close to this dashed line, but the curve will never cross the dashed line. So this is called the vertical asymptote. So this is also a vertical asymptote. This is also a vertical asymptote. This is also a vertical asymptote. Right? Horizontal, another asymptote, the other one is horizontal asymptote. Okay, the horizontal asymptote mean, which is the horizontal dashed line. So that means when the function, right, this is a rational function, when x is increase without any bound or decrease without any bound, then the curve, the f values will very close, the curve will very close to this horizontal line. This horizontal line, if this horizontal line is given by h equals k. Okay. When x is increasing without any bound, then the curve will very close to this horizontal dashed line y equals k. So in other words, when x is very large, then the curve value would be very close to k. When x is very small, the curve will also be very close to k, right? So this kind of dashed line is called a horizontal asymptote. This is also another horizontal asymptote. Right? This is a horizontal asymptote. And this one is horizontal asymptote. Of course, we have other ways. So the question is, how to find the vertical asymptotes and the horizontal asymptotes for a rational function. So here, let's look at the vertical asymptotes, okay? Vertical asymptote, VA. Vertical asymptote of a rational function Rx, which is Px over Qx. So here is the first thing. If you want to find the vertical asymptotes, the first thing is you need to simplify this rational function. Such that there is no common term, okay, to get a reduced form. So in other words, P and Q have no common factors. You cannot simplify anymore. Okay. The second that is you can find the zeros. Find the zeros of the denominator Q of x. Okay. Find the zeros of the denominator of Qx. Then these zeros are vertical asymptotes. Okay. So let's look at a very easy example. This y equals x minus 2, x minus 3. Right? For this example, you can see we cannot simplify anymore, right? For the top and the bottom. So, but we know that the zeros of the denominator, which is you set this one to be 0. So you have x equals 3. So x equals 3 is a vertical asymptote. Okay. So what about the horizontal asymptotes? The horizontal asymptotes of this R equals Rx equals P of x over Q of x. Okay, so you can see that we can write at the beginning, as I did here, Rx, since P, Q are polynomials, it also can be written as this form, right? So now let's look at, let's rewrite this one. So it can be written as a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a1 x plus a sub 0. This is the top. Bottom b sub m x to the m plus b sub m minus 1 x to the m minus 1 plus b1 x plus b sub 0. Right? So how to find the horizontal asymptote? So we have several cases you need to know. If the degree of p of x is less than the degree of q of x, so here for this case, that is n is less than m, then y equals 0 is a horizontal asymptote. The second case, if the degree of p of x, the top, is equal to the degree of the q of x, which it means n is equal to m, then y equals a sub n over b sub m is the horizontal asymptotes. So what is a sub n and b sub m? A sub n is the leading coefficient of the numerator. B sub m is the leading coefficient of the denominator, right? Three, if the degree of p of x, the top, is greater than the degree of q, the denominator. In other words, so the n is greater than m, then there is no horizontal asymptote. Okay? So now let's look at some examples.